Hi, good morning. We're going to look into question 4. This is an 11-mark question on Group 1 Alkali Metals, so let's get moving. Alright, so for the first part of the question, we're going to look into a piece of lithium in the water, and they want you to include the state symbols. Okay, so if you are looking at brackets given to you after the chemical formula, and this is what we meant by formulas, then what essentially they want you to write is the state symbol. Now sometimes students don't read the question, and that's really a pity, because what they end up doing is they try to balance the equation instead. However, if you take a quick look, the equation is already nicely balanced for you in the sense, so you just need to write out the state symbol. So please take some moment in your examination or your test to actually read the requirement of the question. So you need to complete the equation by adding the state symbol. Alright, so as you can see from here, the first one, lithium, because lithium is a metal, I'm going to try to use purple. Okay, so it's a piece of metal, so it's going to be in solid state. Next we have water. So water is liquid state. I've got lots of questions that students ask then, like in this case, like when do we use the L? Okay, L state symbols refers to liquid. Most of the time is usually used on water. Other than that, it is usually used on molten substances. Like for example, if I melt a piece of iron and it become a liquid state, okay, there's no addition of water. It basically means from solid iron, I melt it completely, it becomes liquid state. That is our molten iron there. Okay, and then that's when we use L as well. Okay, then we look into LiOH. LiOH over here is our lithium hydroxide. Now group 1 salt are very soluble in water, so lithium hydroxide is over there. This is technically our alkali as well, and all alkalis are aqueous. So I think the challenge for a lot of students here is, when do we use aqueous and when do we use L, right? So L, as we have mentioned previously, mainly reserved for water or molten substances. You would know it's a molten because they were actually included in the descriptor. Right. For LiOH, what is happening here, because it's an alkali, anything that's an alkali, another group 1 alkali will be sodium hydroxide, okay, or potassium hydroxide. These are really common alkali, as well as acids. Okay, they are like hydrochloric acid, sulfuric acid. Those are always in aqueous state. Okay, and then finally we have our H2. H2 is a G, because G represent gases, so you do need to know what are the common gases in chemistry. So we have like CO2, H2, N2, basically nitrogen, hydrogen, carbon dioxide, methane gas, ammonia gas. I'm going to write down its name because a lot of students tend to like confuse this ammonia with ammonium. Okay, ammonia here is our gas. Ammonium, on the other hand, which is our ion. Okay, if it's in an ion, it usually would be in an aqueous state. That means this substance is dissolved in water. Say for example, if you have ammonium chloride, then we will write down NH4Cl with an AQ sign. Okay, right. So that is how we accomplish a 2 marks state symbol question. This is 2 marks. Basically means if you got any 2 correct, you get 1 mark here. All right. Moving on to the next part. We have observations, so I'm going to try to use blue. We want to observe observation that's made when lithium is added to water. So there are a few reactions or a few observations that you can see, and hopefully you have done this experiment before. So the first one very clearly is the moment you drop the metal in there, you see a lot of bubbling, a lot of effervescence here, right? Okay, and then because your group 1 metals, the first 3, okay, so we have got lithium, sodium and potassium. They have a lower density than water. Okay, so they actually can float on the surface of the water. So if you think that the word float is hard, you can just simply say they move on the water surface. Okay, anything to bring out the idea that they have a lower density than water. So they'll be basically on the surface here. Right? Then as time passes, okay, what's going to happen is the metal itself, they will dissolve in the water. Another way to describe this point here is you could say it gets smaller in the water, or it gets smaller in size. Okay, so dissolve is the word we use. Now, one thing to take note is the opposite of not acceptable answers. Okay, now if you do mention the idea of melting, then it is wrong. The concept is wrong here, because melting basically means a solid turning into a liquid directly. Okay, and we are not melting lithium here. We are putting in a container of water. So because of the presence of water, it actually dissolve, not melt. Okay, like if it's an ice cube and there is nothing you add to it. It just simply that it's on the table and it turns from a solid to liquid. Yes, then that would be considered melting. Alright, another misconception that I tend to propose is the idea of flame and burning. It is not the case. The only time you see flame when you put group 1 metal in water is when it is potassium and below. So cesium, potassium, all those more reactive alkali metal, then you get the flame when you put it in. Okay, it is a very beautiful color in my opinion. Okay, now next one, I'm going to look into 3 marks on mole concept here. So what we have here is we have, there we go. Okay, so we start off with this volume of hydrogen gas, and it tells at room temperature and pressure. They want you to calculate, and you need to show your working. Ideally, you don't just give me your final answer because it's very risky. Okay, show by calculation the mass of lithium that's added between this mass. Okay, so they don't tell you the exact mass of lithium added, so you cannot work backwards. I think that's what has been. This is what has been happening. A lot of students are using the value given and they work backwards. Okay, so they tell you this is the range, and you are supposed to show what is the mass of lithium added. Okay, so I rewrote the entire equation over here at the top. Okay, nothing fancy. It is given to you over at the top, so I rewrite it with the correct balancing coefficient. So I've got 2 in front of lithium and 2 in front of lithium hydroxide. So what I need to know, or what information given to 375, I would usually put my information all over my balance equation first, then I try to see what's my next step. And they want me to find the mass of lithium. So what I do is I put a question mark, and then I put a G above lithium, okay? And then what then? So what is the connection between these two? It's this formula here, this triangle formula, molar volume of gases. Basically, it states that any gases, 1 mole of any gas has a mole of 24 dm cube. Alright, so take note, our unit is different. So first thing you want to do is to cube 2 cm cube. Okay, so that's 1000, you need to multiply by 1000. Okay, so that's my first step. And then what I need to do is to find the mole of hydrogen. Alright, so because the only way to compare between these 2 substances or any substances in the equation is to use the mole ratio. Alright, so that's my first step. I want to find out what's the number of mole of hydrogen first, and I'll use 375 divided by 24,000, and I get this string of numbers, so I just put it there. Okay, then step number 2 is I will try to compare what I call the mole ratio. And how I get this is I look at where hydrogen is in the equation, which is here, and there is no number in front of hydrogen. That basically means it has a coefficient of 1. Then I look into lithium because that's what I need to find, what the question wants me to find, and then I'll look into the coefficient, which is 2. So every time 1 mole of hydrogen is produced, what it means is you need 2 mole of lithium to supply that. Okay, so if we have from our first step discovered the number of mole of hydrogen produced, then I can work backwards to find out what is the mole of lithium actually that's being supplied into the reaction. So in this case it's 0.03125. And then my final step, and you should know this ratio formula really well, mass, mole, and MR. Okay, so this is the triangle. So because the question wants us to find the mass, okay, which is this one, what I need to do is I need to multiply the mole and the MR together. So by multiplying them, okay. In this case, actually it's more of an AR. What's the difference between AR and MR? I've always mentioned in my previous video. AR is looking at the mass of an element or an atom, whereas MR, as the name suggests, is the mass of a molecule. Okay, like for example, H2O is a molecule and has a mass of 2 hydrogen plus 1 hydrogen, so that gives us 18. Okay, but in this case, I'm looking at the mass of lithium, which is an element, just one thing. So 7 is what you can get from the periodic table, and you will get this value of 0.219. And then you always don't just stop there, check, right? So they did mention that the value should be between 0.2 to 0.3, so that means we're on the right track. Okay, they actually allow any answers. If you do round it up to 0.22, you will also get the marks as well. Okay, so that's how we get our 3 marks over here. Alright, I'm going to pause here. Again, like I tried out previously, I'm going to make my video a little bit shorter so it's easier for you to digest. So if you are okay with this, we'll move on to part 2 of this question, which is still going to be the same group 1 alkali metal as well. Alright, see you in part 2 of question 4 later. See ya!